Okay, guys, we want to go through and show you the construction of an isosceles trapezoid. An isosceles trapezoid. We'll begin by the construction of a trapezoid. Of course, by definition, a trapezoid is a quadrilateral with one pair of parallel sides. So to construct it as such, I begin by drawing a segment and a point not on that segment, and then I bring out my parallel condition, parallel line through point C, parallel to AB rather. Okay, and then I come and I construct a point on that line, that parallel line, that point D, and now basically I have the four vertices of my trapezoid. Okay, the four vertices of my trapezoids, which I just connect with segments, and then if I desire, I can go and fill that in with a polygon. Okay, as such, and then always back to where I started. Okay, one alteration with this I want to show is that typically the lettering is consecutively, okay, which hadn't been quite that way here because this is A, B. I want this to read C and this to read D. So no big deal. Right click on it, right click on the point, and rename it. So I want to rename that point C, and click OK, and then this point I want to rename as D. Okay, and now it's labeled in a nice consecutive fashion that I want. Okay, I can now come and right click on this line and choose not to show that. And this is a trapezoid. Okay, it is a trapezoid. It looks to be isosceles, but it's a dynamic trapezoid, which means I can alter it and reshape it, have reconfigurations. Here I can have a trapezoid with not one, but two right angles. Impossible to have one right angle, as we discussed. Okay, so let's go and show you how I would make this isosceles, okay? So I'm going to back out, undo a couple of things that I've done. Undo, 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 okay? And come right back to this stage right here, okay? Whereas now what I want to do is I want to create a perpendicular bisector of AB. So let me call on the perpendicular bisector here of AB. And basically I want to reflect that point C across the perpendicular bisector. So the reflection about that line, this option, reflect point C about this line. There it is. It's going to be tagged as C prime. Wanting to keep these consecutively named, I'll go and rename that as C, and then the other one here as D. Okay, let's just check that again. Rename point as D, and then these define my points of my isosceles trapezoid. So I can now construct the segments, connecting those, and come in drawing in my polygon over top of that. Oops, not where I want it. Okay, draw my polygon from A to B to B to C, C to D, and then back to A. Okay. I can, of course, now choose to hide these parallel and perpendicular lines. So, and this should be a dynamic isosceles trapezoid, meaning that I can manipulate this in any which way. It looks like, look, if I manipulate this enough, it goes to an isosceles triangle, right? Okay. Now, some of the properties, well, let's take a look, all right? I think we know by definition that the legs are congruent, so I can simply click on those and pops my measure and shows me that they are equal regardless of how I manipulate this. Okay. We want to check the angles. Okay. One thing, let me pull this A, just click on it, pull it out. I'll put the angle measure inside. Remember to measure angles. We want to do this consecutively, so we start at B, A, D. That measure is, as indicated there, 56.9. That should be the same measure over here. Okay, so I will click from C to B to A, and I can drag those measures in, and we'll see that they are equal, and that they remain equal regardless of how I manipulate this. Okay, we should also find that these upper base angles are equal as well, so go back and measure them. A, D, C is measured, as is D, C, B, that's being measured. Okay, and drag those in. Okay, and we can see that they are equal, and we can also see that they are supplementary to these angles down here. Okay, so it looks like we got these measured angles in here twice. Not a big deal. Okay, all right. And lastly, we can take a look at the diagonals and illustrate here that not a line, a segment. Okay, segment from A to C and from D to B, and check their lengths, and checking their lengths we will find that they are equal. Okay, check the length. That's not what I wanted. I'm going to undo that. That's not what I was asking. I wasn't asking for it to measure the perimeter. Draw the other diagonal back in. Okay, and then let's go and click on and measure their lengths. Okay, there and there, and you can see that they're equal, and of course regardless of how this is manipulated, they remain equal. Okay, and we can also see that the base angles remain equal, and the same side interior angles remain supplementary as per the properties of a isosceles trapezoid. Okay, so there it is. Okay, and there's how we do the construction. If you missed it or you need another retake on it, there you go.